That would be interesting.
Now it's recording.
We need to get someone who's knows what they're talking about.
Yeah, we have had someone
We have had a person,
right.
we had an Aboriginal man come and talk to us one time.
I'd like to introduce Tony tonight, who's going to give a talk, The Universe in a Nutshell. So, Tony, would you like to start?
Oh, thank you. Yes. Thank you very much, Howard.
Right.
Howard Greg.
Yes.
1G or 2?
2.
At the end or at the beginning?
That's a point.
Or is it one of each?
2 at the end, 1 at the beginning.
So actually 3 Gs.
Yes.
I spelt it wrong on the disc I gave you. Sorry.
Oh, I didn't look carefully.
Oh,
I said that's more or
Howard
less.
Switched
presented
off
last month.
anyway.
Well, hello again. Thank you very much for that lovely introduction, Howard. And
Short and sweet.
tonight we'll talk about short and sweet. I think this might be 2. But anyway, I'll start. Science states that the snail travels at the blistering speed of 0.047 kilometres per hour. The leatherback sea turtle travels at between 1.8 and 10 kilometres per hour. It's not bad for a turtle, I reckon. Now, the average human walks at about 5 kilometres per hour. That same average human runs at about 22, sorry, that's not right, at about 16 to 24 kilometres per hour. Usain Bolt, however, runs at 44.72 kilometres per hour. So he's almost twice as fast as the average person, almost. Wildebeest and lions, believe it or not, tie at 80.5 kilometres per hour each. Not bad, eh? Springboks run at 88 kilometres per hour. Cheetahs run at 109.4 to 120.7 kilometres per hour. Now this probably explains a number of things. Probably explains why snails and leatherback turtles have been a staple diet of human beings for such a long time. And why in places where lions and cheetahs roam, the preferred meal would be a human being. Even the current fastest man on earth, Usain Bolt, can't outrun lions or cheetahs. Now, why have I introduced speed? Well, it's just to try to get an idea of speeds in the universe. Now, we're used to very slow speeds, really, like those speeds, or like driving around our cars and doing speeds that we shouldn't be doing in our cars, which has happened on occasion. Now, Earth's speed around its axis, is 460 metres per second. Now that equates to 1,656 kilometres per hour. Now, in its orbit around the Sun, its speed is 107,000 kilometres per hour. That's not too bad. Our solar system moves at 828,000 kilometres per hour. Now, that's around our galactic centre. Okay? Now, the solar system orbits the galactic centre of the Milky Way once in about 225 to 250 million years, the year, or that particular year, is called the galactic or cosmic year, by the way. Not that it makes any difference, because not many humans would be around to experience the entire galactic year, would they? Now, the speed of the Milky Way as it hurtles towards our nearest galaxy, Andromeda, is 392,400 kilometres per hour. When you start adding all these speeds together, you're starting to get some pretty high speeds. Now, it's calculated that it's going to take about 4 billion years, that's 4,000 million years, before the Milky Way and Andromeda crash into each other. It's going to happen. Again, it's not going to worry us too much for two reasons. One, well, because it's 4 billion years from now and not many of us are going to be around. The other point is that there aren't going to be many humans around there, because the Earth itself has only got an expected life of 4.75 billion years. The Earth itself only has a life expectancy of 4.75 billion years, because that's when the Earth's liquid water runs out. That's what they claim anyway. This is all from science. Now, just to point out that they have already got plans for what they're going to call the galaxies that collide, the Earth, Milky Way and Andromeda when they collide.
So it's really cleaners, we're doing the church tonight instead of tomorrow.
Okay.
Sorry, mate.
You're right. So what's going to happen? So we all would have died out as the result of the loss of liquid water on the Earth in 3.75 billion years from now, and because we had ventured outwards towards other worlds in search of a planet and or solar system that could sustain us in the meantime. When I think about that too, the Hubble telescope went up into orbit, and they focused on the part of space that had the least amount of objects to be seen in the small amount of space that they focused on. And doing a time-lapse photograph, I forget how long it was actually for, it might have been about 24 hours or more, they found it was just packed with galaxies and stars, and more than they could ever have imagined. But anyway, the Milky Way is what's called a barred spiral galaxy, and it's about 100,000 light years across. And it's 100,000 light years, not 100,000, just 100,000 years. It's 100,000 years times the speed of light. So it's a damn big place for something that is seemingly so small, because when we compare it to the other galaxies in the universe, we have something like a couple of not something like, we have billions upon billions of galaxies in our universe. Billions. Just compose myself. Spiral galaxies make up about 2/3 of all the galaxies in the universe. Now, unlike a regular spiral, a barred spiral contains a bar across its centre region and has 2 major arms. The Milky Way also contains 2 significant minor arms as well as the 2 smaller spurs. Now, one of the spurs, known as the Orion arm, contains our solar system and of course our sun. And the Orion arm is located between 2 major arms, Perseus and Sagittarius. The Milky Way does not sit still, but is constantly rotating. As such, the arms are moving through space. The Sun and the solar system travel with them. The solar system travels at an average speed of 515,000 miles per hour or 828,000 kilometres per hour. Even at this rapid speed, the solar system would take about 230 million years to travel all the way around the Milky Way. I've already said that, haven't I? Spiral arms are like traffic jams in that the gas and stars crowd together and move more slowly in the arms. As material passes through the dense spiral arms, it is compressed, and this triggers more star formations. Our galaxy is surrounded by an enormous halo of hot gas that extends for hundreds of thousands of light years. Hundreds of thousands. And this is not unusual. This is typical of many of the galaxies out there. The gas halo is estimated to be as massive as all of the stars in the Milky Way. Like the galaxy itself, the halo is spinning rapidly. Now, curled around the centre of the galaxy, the spiral arms contain a high amount of dust and gas. New stars are constantly formed within the arms. These arms are contained in what is called the disk of the galaxy. It is only about 1,000 light years thick. So at the centre of the galaxy is the galactic bulge. The heart of the Milky Way is crammed full of gas, dust and stars. The bulge is the reason that you can only see a small percentage of the total stars in the galaxy. Dust and gas within it are so thick that you can't even peer into the bulge of the Milky Way, much less see out the other side. Tucked inside this very centre of the galaxy is a monstrous black hole, billions of times as massive as the Sun. This supermassive black hole may have started off smaller, but the ample supply of dust and gas allowed it to gorge itself and grow into a giant. The greedy glutton also consumes whatever stars it can get a grip on.
Sounds like Kronos.
Yeah. Although black holes cannot be directly viewed, scientists can see their gravitational effects as they change and distort the paths of the material around it, or as they fire off jets. Most galaxies are thought to have a black hole in their heart. Now, whether that's what actually causes the spinning of those black holes, I'm not certain. But it has been suggested that such anyway is caused by the momentum caused by the Big Bang. Dark matter is estimated to make up 90% of the mass of the galaxy. Recently, measurements have weighed the galaxy at between 400 billion and 780 billion times the mass of the Sun. They're phenomenal figures when you think about them, aren't they? By focusing on how the Milky Way affects its neighbouring global clusters, dense groups of stars smaller than a galaxy, scientists were able to calculate the mass of the Milky Way at varying distances. The results can help them improve their understanding of how much of the galaxy is made up of ordinary materials like dust and stars, and how much is composed of dark matter. Even though we know that dark matter should be there, and we think it should be there, the ratio of dark matter to luminous matter in particular galaxies may be under debate. The Milky Way contains over 200 billion stars. And you think about that, and you think about the concept of, even if it was only 10% of those having their own solar systems, and of those only 10% again having the chance of life, we would be abundant with life in this galaxy alone, without looking at the other billions and billions of galaxies out there. Amazing. The solar system lies about 30,000 light years from the galactic centre, and about 20 light years above the plane of the galaxy. Now, Earth and its neighbours don't orbit within the plane of the galaxy, but are instead tipped by about 63 degrees. So they're kind of above, there's the plane of the galaxy like that, and they're sitting up there like, that's 63, so they're like, that's about 63 degrees. So they're actually sitting up here like this, above it. How they work this out, I don't know, because as you can imagine, having to peer through telescopes and work it out, I just don't know. I wouldn't have a clue. This information has come from a site called space.com. More than half the stars found in the Milky Way are older than the 4.5 billion years old, older than our 4.5 billion year old Sun. Galaxies like ours typically undergo a stellar baby boom, churning out stars in enormous quantities roughly 10 billion years ago. Now, the most common stars in the galaxy are red dwarfs, a cool star about 1/10 the mass of the Sun. Now, once thought unsuitable for potential life-bearing planets because such bodies would have to be too close to meet the criteria, red dwarfs are now considered potential suspects. As late as the 1920s, astronomers thought all of the stars in the universe were contained inside of the Milky Way. It wasn't until Edward Hubble, and he of course is the person who the Hubble telescope was named after, discovered a special star known as a Cepheid variable, which allowed him to precisely measure distances that astronomers realised that the fuzzy patches once classified as nebula were actually separate galaxies. NASA recently selected the Galactic Extragalactic ULDB Spectroscopic Terahertz Observatory, GUSTO for short, mission to fly a telescope carried by balloon to map out large sections in the Milky Way and nearby large Magellanic Cloud. The mission plans to launch in 2021 from McMurdo, Antarctica, and should remain in the air between 100 and 170 days, depending on weather conditions. So maybe science was finally ready to tackle the mystery of what made the Big Bang go bang. And if so, then maybe science could also address one of the deepest questions of all: what came before the Big Bang? According to the Big Bang theory, the whole universe emerged during a single moment, some 13.7 billion years ago. In the competing theory, our universe generates and regenerates itself in an endless cycle of creation. That in itself sounds a little theosophical. The latest version of the cyclic model even matches key pieces of observational evidence supporting the older view. Now, this is the most detailed challenge yet to the 40-year-old orthodoxy of the Big Bang. Some researchers go further and envision a type of infinite time that plays out not just in this universe, but in the multiverse, a multitude of universes, each with its own laws of physics and its own life story. Still others seek to revise the very idea of time, rendering the concept of beginning meaningless. All of these cosmology heretics agree on one thing: the Big Bang no longer defines the limit of how far the human mind can explore. The Toy Story character Buzz Lightyear, I'll start that one again. Toy Story character Buzz Lightyear's catchphrase, "to infinity and beyond," encapsulates in just those 4 words the hopes and dreams of many. But really, would it ever be possible to reverse the universe and explore as much as we choose to do so within our own single lifetime? There are theoretically 2 ways to explore the universe. The first is available to all of us, that is through astral projection, where at the speed of thought you will whisk your astral body to the far reaches of the universe to explore and discover at your whim those places and worlds of interest to you. But the question that arises from such travel is the astral projection you are witnessing a part of the real universe or the astral universe? They may or may not be the same. Mexican physicist and Star Trek fan Dr. Miguel Alcubierre wanted to know if it was possible to create warp speeds. In the early 1990s, he devised a theory in which you could travel faster than the speed of light by not moving. In effect, the theory suggested that travelling faster than the speed of light was similar to riding a wave on a surfboard. It is not the surfboard that moves, but the wave. Alcubierre's theory suggested that it would be possible to push and pull a spacecraft along a trajectory on a wave of space. It would be the wave of space moving and not the craft, and as such, the theory of relativity would not be broken, and yet the craft could travel many times faster than the speed of light. It is suggested that a journey to our nearest star and solar system, Alpha Centauri, which by the way is the target of the TV show Lost in Space and the crew of the Jupiter 2, instead of taking 180,000 years using our fastest rockets today, or 4.1 light years travelling at the speed of light, it would be possible to get there in just 2.5 weeks. The thought has excited many scientists around the world, and me as well, I think. And currently many are giving the idea thought. When the theory first arose, it was thought that in order to achieve such velocity, it would take all the energy available in the universe to make it viable. In the ensuing years, that has been re-evaluated, and it is suggested that it will indeed be possible one day. I don't know if you can see that, but that is a rendering of what they think one of these spacecraft will look like. You have the craft itself in the middle, and around it is this circular thing. And I think that's the part that projects the push-pull method of getting you through the wave. The Alcubierre drive, as it's now called, is a speculative idea based on a solution of Einstein's field equation in general relativity, as proposed by the Mexican theoretical scientist, the physicist Miguel Alcubierre, by which a spacecraft could achieve apparent faster than light travel if a configurable energy density field lower than that of vacuum, that is negative mass, could be created. Heavy science. Now, theories of the formation of the universe. One of them is called the incredible bulk. In the 4th century AD, St. Augustine pondered what the Lord was doing before the first day of Genesis, rarely repeating the exasperated retort that he was preparing hell for those who pry too deep. In 1929, Edwin Hubble determined that the universe was expanding. Extrapolated backward, Hubble's observation suggested the cosmos was flying apart from an explosive origin, the fatal Big Bang. The event was not an explosion that occurred at some point in space and time. It was an explosion of space and time. In this view, time did not exist beforehand. It is hard to imagine time just starting. How does a universe decide when it's time to pop into existence? In the standard Big Bang model, the universe began in a state of near infinite density and temperature. At such extremes, the known laws of physics break down. To push all the way back to the beginning of time, physicists needed a new theory, one that blended general relativity with quantum physics. The prospects for making sense of the Big Bang began to improve in the 1990s as physicists refined their ideas in string theory, a promising approach for reconciling the relativity and quantum views. Nobody knows yet whether string theory matches up with the real world. The Large Hadron Collider, a particle smasher, has already inspired stunning ideas about how the universe was constructed. Most notably, current versions of string theory posit 7 hidden dimensions of space in addition to the 3 we experience. Strange and wonderful things can happen in those extra dimensions. The key concept turned out to be a brain, a 3-dimensional world embedded in a higher dimensional space. The term in the language of string theory is just short for membrane. A sheet of paper blowing in the wind is a kind of 2-dimensional membrane, tumbling through our 3-dimensional world. Our entire universe is just one sheet, or 3D brain, moving through a four-dimensional background called the bulk. Our brain is not the only one. There are other moving through the bulk as well. Just as two sheets of paper could be blown together in a storm, different 3D brains could collide within this bulk. The equations of string theory indicated that each 3D brain would exert powerful forces on others nearby in the bulk. Vast quantities of energy lie bound up in those forces. A collision between two brains could unleash those energies. From the inside, the result would look like a tremendous explosion. Even more intriguing, the theoretical characteristics of explosion closely match the observed properties of the Big Bang, including the cosmic microwave background, the afterglow of the universe, fiercely hot early days. It meant colliding brains could explain one of the key pieces of evidence people use to support the Big Bang. Another of the theories is called time's arrow. The real problem is not the beginning of time, but the arrow of time. Looking for a universe that repeats itself is exactly what you do not want. Cycles still give us a time that flows with a definite direction, and the direction of time is the very thing we need to explain. Time's arrow and time's beginning cannot be treated separately. There is no way to address what came before the Big Bang until we understand why the before precedes the after. As well as adding more dimensions, this theory wants to add more universes, a whole lot more of them, to show that in the big picture, time does not flow so much as advance symmetrically backward and forward. Time is an illusion, with each moment, each now, existing in its own right, complete and whole. The one-way progression of time, always into the future, is one of the greatest enigmas in physics. The equations governing individual objects do not care about time's direction. Imagine a movie of two billiard balls colliding. There is no way to say if the movie is being run forward or backward. But if you gather a zillion atoms together in something like a balloon, past and future look very different. Pop the balloon and the air molecules inside quickly fill the entire space. They never race backwards to reinflate the balloon. In any such large group of objects, the system trends towards equilibrium. Physicists use the term entropy to describe how far a system is from equilibrium. The closer it is, the higher its entropy. Full equilibrium is, by definition, the maximum value. So the path from low entropy, all the molecules in one corner of the room unstable, to maximum entropy, the molecules evenly distributed in the room, stable, defines the arrow of time. The route to equilibrium separates before from after. Once you hit equilibrium, the arrow of time no longer matters because change is no longer possible. Our universe has been evolving for 13 billion years, so it clearly did not start in equilibrium. Rather, all the matter, energy, space, and even time in the universe must have started in a state of extraordinarily low entropy. That is the only way we could begin with a Big Bang and end up with the wonderfully diverse cosmos of today. Understand how that happened and you will understand the bigger process that brought our universe into being. Why did the initial setup of the universe allow cosmic time to have a direction? There are an infinite number of ways the initial universe could have been set up. An overwhelming majority of them have high entropy. These high entropy universes would be boring and inert. Evolution and change would not be possible. Such a universe could not produce galaxies and stars, and it certainly could not support life. It is almost as if our universe were fine-tuned to start out far from equilibrium, so it could possess an arrow of time. But to a physicist, invoking fine-tuning is akin to saying a miracle occurred. The challenge was finding a process that would explain the universe's low entropy naturally within any appeal to incredible coincidence, or worse, to a miracle. One of the other theories is called the steady state theory, and it fell out of favour when the Big Bang theory came in. So in the steady state theory, as galaxies moved apart, the idea was that new galaxies would form from matter that was supposed to be continually being created throughout space. The universe would have existed forever and would have looked the same at all times. Well, this last property had the great virtue, from a positivist's point of view, of being a definite prediction that could be tested by observation. The Cambridge Radio Astronomy Group did a survey of weak radio sources in the early 1960s. They were distributed fairly uniformly across the sky, indicating that most of the sources lay outside our galaxy. The weaker sources would be further away on average. The steady state theory predicted the shape of the graph, the number of sources against source strength, but the observation showed more faint sources than predicted, indicating that the density sources were higher in the past. This was contrary to the basic assumption of the steady state theory, that everything was constant in time. For this and other reasons, the steady state theory was abandoned. And the last of the theories I want to look at was the creationist view. Of course, most of you will know that creationists is a religious view. So many religious persons, including many scientists, hold that God created the universe and the various processes driving physical and biological evolution, and that these processes then resulted in the creation of galaxies, the solar system, and life on Earth. This belief, which is sometimes termed theistic evolution, is not in agreement with scientific explanations of evolution. Indeed, it reflects the remarkable and inspiring character of the physical universe revealed by cosmology, paleontology, molecular biology, and many other scientific disciplines. The advocates of creation science hold a variety of viewpoints. Some claim the Earth and the universe are relatively young, perhaps only 6,000 to 10,000 years old. I do have a problem with that. These individuals often believe that the present physical form of Earth can be explained by catastrophism, including a worldwide flood, and that all living things, including humans, were created miraculously, essentially in the forms we now find them. Other advocates of creation science are willing to accept that Earth, the planets and the stars may have existed for millions of years, but they argue that the various types of organisms, and especially humans, could only have come about with supernatural intervention because they show intelligent design. In his booklet, both these young Earth and old Earth views are referred to as creationism and special creation. There are no valid scientific data or calculations to substantiate the belief that Earth was created just a few thousand years ago. This document has summarised the vast amount of evidence for the great age of the universe, our galaxy, the solar system, and Earth from astronomy, astrophysics, nuclear physics, geology, geochemistry and geophysics. Independent scientific methods consistently give an age for Earth and the solar system of about 5 billion years, and an age for our galaxy and the universe that is 2 to 3 times greater. The conclusion makes the origin of the universe as a whole intelligible, lend coherence to many different branches of science, and form the core conclusions of a remarkable body of knowledge about the origin and behaviour of the physical world. So a theosophical theory of the life of the universe, I believe it starts with the Manvantara, which of course is the age of Manu, the Hindu progenitor of humanity, an astronomical period of time measurement, and Manvantara is a Sanskrit word, compounded Manu and Tara, meaning the duration of a Manu or his lifespan. I won't go into that, but suffice it to say, it's a long time. Something like 306,720 million human years. And there are 7 rishis of Antara, equals 71 times the number of years contained in their 4 yugas, etc. The cardinal principles are one, that there exists an omnipresent, eternal, boundless and immutable principle from which the visible world arises. Universes come and go, and our universe is the periodical manifestation of immaterial reality. The universe, with everything in it, is temporary compared with the eternal immutability of the One. Everything in the universe, throughout its kingdoms, is conscious of its own nature and degree. The universe is not the product of chance, but is worked and guided from within. The whole order of nature gives evidence of purposiveness. Every individual is fundamentally identified with the universal oversoul and evolves through cycles of reincarnation in accordance with the law of cause and effect called karma. The process of cosmic manifestation is considered to have 2 phases. The first is involution, during which billions of units of spiritual consciousness, called monads, emerge from the one undifferentiated source. They continually become more deeply involved in matter, in the mineral, vegetable and animal kingdoms, and through the limitations and impacts of this condition, finally attained self-consciousness in the human kingdom. The second phase is evolution, during which these self-conscious units, as humans, gradually unfold the potential inherent in them from the beginning of self-conscious units as humans. I've doubled up. Beginning of the cycle, attain freedom from attachment to matter, and eventually return to the source from which they came, but with an incalculable increase of consciousness as a result of their aeonic pilgrimage. Theosophy denies that the human spirit can ultimately be lost, because it is intrinsically eternal and indestructible. Through successive re-embodiments in physical form with accompanying emotional, mental and psychic responses to experience, the spirit attains mastery over its vehicles and man reaches the expression of his godhood. The most precise measurement ever made suggests our universe is expanding much faster than previously thought, casting doubts on earlier predictions and even calling into question Einstein's theory of general relativity. Just as the universe started after a Big Bang, astronomers are now attempting to study this expansion to predict how the universe will ultimately end. The rate of this expansion may eventually tear the universe apart, forcing it to end in a big rip. Alternatively, the universe could shrink, decrease or decay, effectively reversing the Big Bang and destroying the universe in a big crunch. A third theory is described as the Big Freeze. Many theoretical physicists believe the universe will end, and it could happen at any point between 2.8 billion and 22 billion years from now. Certain researchers even suggest the process of its demise has already begun. So what fate is awaiting our universe? The expanding universe? For a long time, scientists, including Albert Einstein, thought the universe was static and infinite, explained Thomas Kitching, lecturer in astrophysics at University College London. Observations have since shown it is in fact expanding at an accelerating rate. This means it must have originated from a more compact state that we call the Big Bang, implying that time does have a beginning and it would likely have an end. By studying ancient light, astronomers can see the so-called relic radiation from the Big Bang, also known as cosmic microwave background. As the name suggests, Einstein's special theory of relativity shows that time is relative. The faster you move relative to me, the slower time will pass for you relative to my perception of time. This means that in our universe of expanding galaxies, spinning stars and planets, experiences of time vary and everything's past, present and future is relative. Cosmologists have used this theory as well as data from studies of cosmic background radiation to determine the cosmic age of the universe to be around 13.799 billion years old, and this can help predict how and when the universe could end. The Big Freeze. The most widely accepted theory is that the universe will eventually come to an end. It will most likely do so trillions of years from now, when the entire span of the cosmos is empty and just a notch above absolute zero. We sometimes refer to this fate as the Big Freeze. Why, you ask? Out of respect for the law, specifically the second law of thermodynamics, which tells us that total entropy, basically chaos, in the order of the universe always increases. The second law of thermodynamics is one of the supreme laws in all of physics. If a scientist proposes a theory that violates it, he's in big trouble. Chaos and disorder. Doesn't that suggest a particular violent end rather than a big chill? Well, entropy doesn't necessarily refer to dramatic destruction. It's more about how stuff just tends to fall apart. Think about food sitting on your kitchen counter or the refrigerator for an extended period of time. It will eventually rot. Or your car, which will begin to rust, decreasing its original strength. The refrigerator, the example you're most likely familiar with is the way your body undergoes decline as it ages. Your vision and hearing gets worse. You're not as strong as you used to be. Your hair thins. You start to get wrinkles, and eventually your bodily processes begin to shut down. Entropy is unique because it's the only quantity in the physical sciences that indicates a particular direction for time, the arrow of time. It tells us that there is no hitting the rewind button to the beginning of the universe. So the galaxies of the universe will eventually disintegrate. Dead dwarf stars will drift away into the darkness along with the hulks of neutron stars, and everywhere there will be black holes. There are an estimated 70 sextillion stars in the visible universe, organised in billions upon billions of galaxies. To put things in perspective, that's 70,000 million, or 7 followed by 22 zeros, and about 10 times as many stars as grains of sand on all the world's beaches and deserts. A number so large it's almost impossible for us even to imagine. Right now we are in the stelliferous age of the universe, the period in the life of the universe where there are still stars. Yet, when the entire age of the universe is taken into consideration, it turns out the stars burn brightly only for a very short time. 1 trillion years from today, almost all the stars will have burnt up all their nuclear fuel. 1 trillion years after that, even the black holes will have disintegrated. After that, even the protons themselves will begin to decay. The universe will then become a freezing mist of electrons and eventually approach absolute zero. At this point, all motion stops, and that's the Big Freeze. Theosophical theory and the repose of the universe. We're talking about pralaya, and that, as my understanding, is a dissolution which specifies different periods of time during which a non-activity situation persists as per different formats and contexts. The word Mahapralaya stands for great dissolution. During each pralaya, the lower 10 realms are destroyed, while the higher 4 realms, including Satya Loka, Tapaloka, Yana-loka and Mahaloka, are preserved. During each Mahapralaya, all 14 realms are destroyed. In the Samkhya philosophy, one of the 6 schools of classical Indian philosophy, pralaya means non-existence, a state of matter achieved when the 3 gunas, principles of matter, are in perfect balance. The word pralaya comes from Sanskrit meaning dissolution, or by extension, reabsorption, destruction, annihilation, or death. Coming to the conclusion, the setting of this realm began many, many eons ago, in a time before time. In the beginning was the One and nothingness. No space existed, no time, no life. The ultimate supreme being, the One, saw that nothing was and planned to make it so. A vagueness the size of a nutshell, that's where it comes from, began to form in the nothingness. As the nutshell grew, esoteric matter, a part of the One, seeped through the nothingness, creating the foothold required by material life to exist. In a sudden, violent act, matter that had never been attached itself to the esoteric matter and spewed forth from the nutshell-sized weakness into the fabric of nothingness and expanded outwards in all directions, creating as it went a soup of elements that would eventually become all forms of life, known and unknown to us, in a universe expanding ever outwards, surrounded by the nothingness. This all occurred many billions of years ago. This universe in which we reside has come and gone many times during times of Manvantara and Pralaya, wake and sleep. Many times all has been reset so that others, a part of the divine as are we, experience the life of the universe. Those from the previous awakening who had achieved all in the previous existence that they were meant to are moved onward and upward towards the One, learning as they go how to form their own universe, creating their own Big Bang, and unfolding their own universe according to their own laws. Thus there is not one but many multitudes of universes created by their own gods, who in turn had been created by the One. I presented a talk tonight that I believe is filled with hope for the future of humankind. I hope that envisions the greatest journeys ever to be undertaken to the outer edges of our very universe. Both science and philosophy seem to be merging somewhat in their understanding of the universe and their acceptance of the Big Bang theory. I, for one, am heartened by the changes to this theory and how it is tending towards a concept of universes. If we are ever able to travel as spacefarers throughout our universe, at a moment's whim by man-made spacecraft riding the waves of space at many times the speed of light to explore all around us, how will we navigate our way back home? Science tells us that there are billions of galaxies out there, and that 2/3 of them are spiral galaxies with a central bar like ours. What will distinguish us from all the others? Given that there is no up or down in space, what will prevent us from being hopelessly lost in space?
I understood that one of the latest theories to do with dark matter, etc., was whereas they said the galaxies were moving out from the central core because of the Big Bang, they're now postulating that the galaxies themselves aren't moving with force outwards, but what is happening is that the material between the galaxies is expanding, like on the surface of a balloon. As the balloon pumps up, everything points on it that are marked separate and go further and further apart from one another, which and that's caused what they think is the result of dark matter in the universe, which they still can't explain properly. There's a statement in The Secret Doctrine where she says something about it expands like the bud of a lotus, but I thought the actual words in that sort of went with this concept of this expanding universe between the galaxies. There's a lot of different ideas about it all to try and think about.
There was a idea talking about this expansion, and the earlier idea of the speeding up of the universe being your balloon idea, as it expands the distance between galaxies, solar systems and so on, increases, therefore the gravitational attraction gets weakened, and that's, it doesn't really explain why it's speeding up, but that's a sort of a justification why it's speeding up. So that was one idea. It's probably quite old now. It's probably about 10 years old.
Well, it's a good thing I've read the first volume of The Secret Doctrine, and I thought Manvantara, I took it to mean like an eternity. So people use the phrase eternity of eternities and talked about Brahma having days and nights, and he or she goes to sleep, wakes up, creates another universe or universes for so many billions and trillions of years, does all this creating, and then says, okay. So I would say that the Big Bang fits in with that, you know. Brahma wakes up, Big Bang. Brahma's decided it's time to go to sleep, okay, sun goes supernova, pulls all the planets in, they all go back into source, Brahma goes to sleep for the night again.
And probably the question would be, is it, the scientists have been trying to say that the Big Bang was all of the galaxies we see, but it may only be galaxies in a particular area. There's a Big Bang creation process in a particular area, but there's still always galaxies out there and universes, etc. So there's always, where there's Pralaya in one part, there's Manvantara in another part.
Well, apparently, according to some rabbinic literature, there's a statement that before God created this world, he created and destroyed other worlds, which is something you don't really get in Christianity, which is interesting. So, yeah, there's to it.
A scientist, Dr. Hagelin, I think his name was, who I saw give a talk, it was on a YouTube thing, where he talked about, in the Big Bang Theory, they talk about at the beginning, everything is done in tones of vibration, and the vibrations start off, and I don't know how the hell they work this out, but it goes 8, 16, 32 and 64 of the vibrational, increasing vibration. And in the Vedas originally were sung on a particular tones, and the tones are 8, 16, 32 and 64.
Which keeps doubling as you go up, of course.
Something like that, yes. But they weren't, those aren't exact numbers, I can't, because I think there's a 96 in there too, but when he talked about it, he was saying that the Vedas themselves had the same mathematics and concepts of vibrations as the concepts that they're exploring in Big Bang Theory. I've sort of always been a bit anti-Big Bang Theory, but in recent times I've started to think more to that line because of. But I just consider that it's not that everything began with that. There are times before the Big Bang Theory.
Well, I think there are lots of Big Bangs.
Yes.
Every time Brahma wakes up, there's a Big Bang.
Yes.
And I think that's where one of the examples in that was the use of string theory added to the Big Bang Theory, where you had the pieces of paper that were hitting each other, and when they hit was when a Big Bang occurred.
Mm-hmm.
And that's, to me, explained a lot about the formation of universes in my mind.
Because the other aspect of it too is that when Secret Doctrine talks about a Manvantara coming into being, it's not the physical, it's the superphysical which eventually becomes the physical. And this is just my limited understanding, in quantum physics they say that when you split all the subatomic particles down to a point where you get vibration,
Yeah.
that vibration pulsates in and out of existence all the time. And to me that shows that there are two worlds
Yes.
already just at that point. And so therefore the concept of a Big Bang at this point in time with science is only on the physical world, but there's the actual world is coming out of the supernatural, not supernatural, but so we've got physical, astral, mental, spiritual, etc. It's coming out of those worlds and back in again.
It sounds similar to Kabbalah. It talks about different planes, but it's like you create something. If I want to make a dress, if somebody wants to write a story, it starts in your mind,
Yes.
and eventually you write it.
Yeah.
Yeah.
Actually, has anyone here ever watched Stephen Colbert on Late Night from America?
No. No.
The other couple of weeks ago he had on Neil deGrasse Tyson, the astronomer. He's a black African man. Absolutely brilliant. I like listening to him. Whereas most scientists are very boring to listen to, he's actually got personality. And Colbert, who is Catholic by religion and says he doesn't practice anymore, but the Catholicism still comes through in his thinking. He was questioning the fact that recently scientists discovered, you know how the solar system is basically on a flat plane, that there was some sort of object came through the plane from top to bottom rather than from the side, and it was elongated like a cigar shape. And Colbert, he was sort of a little bit tongue-in-cheek, but he was saying to him, but UFOs, some of the UFOs have that cigar-shaped thing, and he'd say, couldn't have been a UFO. He'd say, no, he said it was an asteroid. He said, well, people don't realise that asteroids are not solid rock, they're actually a whole lot of rocks pulled together by gravity. But as they move through, say, the gravity of the sun, it sort of pulls them apart and it gets this elongated shape. And Colbert picked up I think it was an orange, and threw it at him. Not to hurt, just sort of threw it. And said, yes, he understood it's gravity that makes the orange fall, but I pushed it. And what he was trying to say was, there's another principle. You may call it God, but you might call it spirit, you might call it whatever. But it was, I remember Tyson sort of sat there and he went, yes. He didn't know how to quite answer that concept, but I thought it was a rather clever way of making the point that there are other factors in the world apart from the physical and the laws of nature, the gravity laws, etc.
I've got a question for Tony.
Doesn't mean I can answer it.
I'm curious, right at the beginning you talked about the loss of water. from Earth.
Where does it go?
How is that happening?
It's not happening now. They claim it's going to happen about 3.75 billion years from now. And my thought of that would be it has something to do with the expansion of the sun.
Oh, yeah.
Just boiling away.
So go into space.
Yeah.
Oh, well, by that stage I'll be incarnated living on another planet somewhere, so...
Either that or I'm going to take one of Alcabea's spaceships and fly off to the other side of the universe and not worry about being over here.
Or I might just return to source.
The other one is of course, the question about dark matter. Not all dark matter is
good.
Is good, yeah. Some is purely dark because it's unlit by a sun. But there's two. I'm just pointing out there's two aspects to this. It's not just one. You can have fields of rocks, for instance, which are unlit by the sun, and if we fly through that field, I can't remember the field.
We'd probably go splat.
Yeah, kind of, because you can't see it, because it's not visible. So, but of course, the dark matter that you're referring to is not. That's the unaccounted matter. So, I'm not quite sure where, because they also talk about dark energy,
Yeah.
and that's another aspect from dark matter. So,
And again, it supposedly makes up the most of the matter
Yeah,
in the universe.
Yeah.
So,
There's another,
like about 80% or something ridiculous. So,
there was another theory came out recently. I don't know whether you heard about it. Something that where there's a black hole, they've always theorised that everything that got to near the black hole got sucked into it.
yeah,
But now they start to say, no, there's a rim around the black hole. I'm not quite sure what it was
the
made
event
out of.
horizon.
And as energy and matter hit that thing, they disintegrate. So it's not disintegrating in the hole, but on the peripheral of it.
Yeah,
Have you heard that one?
yeah. I do know that a lot of objects that hit it sort of go into a spin, very fast spin.
Right.
And they turn into spaghetti.
Yeah, and hypothetically, the time, if you ever got into this unfortunate thing, time would actually slow down dramatically. It's another weird thing.
And you're pretty well in the event horizon. Is that what it's called?
Yes, event horizon. Yeah.
The
Event horizon.
expansion on that, you're talking about, where was that large black hole you referred to?
Oh,
Seven,
again, like the centre of our galaxy.
Yeah.
It's in our galaxy.
Yeah.
Yeah, but there'd be one in most galaxies.
Yeah, but it's not small.
No, it's damn big. But then again, our galaxy is damn big.
Yeah,
And you wouldn't even notice it.
How long before we get sucked in?
Billions upon billions upon billions of years. And our planet's only going to be around for 3.75 billion, so what's it matter?
Oh, better start packing now.
What was that movie a couple of years ago where they go through?
Oh, Event Horizon.
Was that what it was called? The
Yeah.
one with Matthew McConaughey.
Oh, no, that's Contact. Oh, sorry. No, you're talking about the one with Jodie Foster and Matthew McConaughey.
Jodie Foster. He goes through the black hole, the ship, and he eventually gets caught in a time thing.
Interstellar.
Interstellar, that's right, yes. Yes, that had some rather interesting concepts in it.
Yeah.
Because he comes back and he's in a different time zone.
Yeah, yeah. I think in a way he could see the universe that he was in, that he came from, but they couldn't see
To
him.
him, yes.
And time had passed centuries or something.
Mm.
But yeah, Archer.
Mm.
Yeah.
Mm,
Very interesting talk.
yes.
Thank you, Tony.
It's amazing how fast we're moving through space, isn't it?
But you just don't realise the and believe it or not, that's why I included a bit about the stars, just to kind of give a comparative at the difference.